Hello everyone. In this session, we are going to discuss about project number one. The name of our project is remote control operation using OSR instruction. So normally, we are using the remote for controlling the number of electrical devices like television, motor, or robot, or anything. Okay, so which we can operate by using the remote. The same project which we are going to design by using the PLC. So for that purpose, we require some hardwares, we require some the software addresses, some software instructions. So along with that, we should know the proper condition. So let us throw some light and let us discuss about the project in detail. Now here you can see the project requirement. In the project requirement, the first of all, we require two hardware devices. The first one is one start push button, and the second one is one DC motor. Right? So here we have to control the on-off operation of our motor by using only one push button. Now the second requirement, the required software instructions and the addresses. So for that purpose, we need to design the program. So in order to design the program, we require one dummy address, one OSR instruction. In order to design the logic, indirectly we are using the logic of XOR gate and the holding operation. Means this is the programming part actually. So while designing the program, I will explain this part in detail. So what exactly the meaning of OSR instruction and how to use this OSR instruction in order to execute the remote control operation. Basically, the OSR instruction is helpful for executing and performing the remote control applications. Now coming toward the project description, means what exactly we are going to implement, we are going to design, and what we are expecting from our project. So these are the two conditions, condition number 1 and condition number 2. So in condition number 1, when we press the button, the start push button, the motor will start, and even if you release the button, the same button, the motor will continue to run. So this is our first condition. And what about the condition number 2? In the condition number 2, when we press the same button again, because we have only one button. Okay. So when you press the same button again, the motor will stop, and even if you release the same button again, the motor will remain off. So these are the two conditions, and which are related to the start push button and the DC motor, right? So I'm again repeating the condition number 1 and condition number 2. In condition number 1, what we are expecting, when you are pressing the button, the motor will start. Even if you release the same button, the motor will continue to run. And what about the condition number 2? When you are pressing the same button again, the motor will stop. And even if you release the same button again, the motor will remain off. Now, based on this condition, let us design this program in our software. Now, here you can see I have mentioned the working of OSR instruction. Okay. Means before coming toward the programming part, at least we should aware about the meaning of OSR instruction. So the OSR means what? One shot rising. It means that if you are using this OSR instruction for designing your project, it provides a single pulse for one scan cycle. One scan cycle means what? So when you are pressing the input, then input will get processed and it will execute the given input, and accordingly we will get the output. Okay, means start from input and getting to output, for that whole process, what we can say, one scan cycle. Okay, means for that one scan cycle, OSR instruction will provide one scan cycle. Okay, it means it provides a single pulse for one scan cycle. Okay, now let us use the one push button. So here I am using one push button. this is our push button. Simply you can provide the description, start push button, start push button, and the operation that will be praise and release, praise oblique release. Operation. Okay, I'm again repeating the working of the OSR instruction. The OSR instruction will provide a single pulse for one scan cycle. Even if you are pressing the push button continuously, doesn't matter. Okay, so it will provide, it will grab and capture the only one pulse and send it to the output. Okay, now here you can see. So for the OSR instruction, you have to click on a bit, and in the bit section, you will get the OSR instruction. Click on OSR. So this is the OSR instruction. So the location of OSR instruction, that should be between the real input and the output coil. And basically the address which we need to provide the OSR instruction, that will be the dummy address or the binary bit, because this is the software instruction, and in order to execute the role of OSR instruction for our project, simply we can provide the binary address, no need of any real input. Now in data file you can see the binary address is here. So why we are using the binary address? Why not the real input address? Because in our project requirement we have mentioned the use of one start push button and one DC motor, means only one digital input and only one digital output. So we cannot use the more than one input, real input in this project. So that is the reason, in order to complete the logic and the project for our this mentioned project, what we are using the binary addresses. Okay, means you can use the binary address as an input as well as the output also. Always remember. Now I am providing the description. It will generate. Okay, so I'm just writing shortly to generate the pulse. Now on the output side, we cannot directly provide the real output address, because we have to fulfill both the conditions, condition number 1 and condition number 2, right? So here I am again using the binary output, because we cannot use the more than one output. So it will capture the pulse, receive the pulse which is coming from OSR instruction. Press the enter button. Okay, so here I am providing, just a minute, instead of symbol, here I am providing the description. Receive is pulse from OSR. Right? Press the OK button. Okay. Now, as per the discussion, we know that OSR will provide a single pulse. So first of all, I am showing you how it will generate the pulse and how you can able to monitor and supervise the pulse on the output side. Okay. Now let us test this OSR instruction. Now first of all, verify it and download the program. Like this. Okay. Now your task is to observe the output. Okay. So here when I press this push button, then accordingly it will generate the pulse on output side. Okay. This, as per our discussion, as per the discussion in the previous sessions, we know that when we press the start push button continuously, the output will remains on, and when I release the push button, our output will be turned off. But here you can observe something different. See, here I am pressing the start push button. It will send the single pulse. It will send the single pulse. Means here we have continuously pressed the push button, means the power supply. We are providing the continuous power supply, but this continuous power supply will not be provided to our output, because we have added OSR instruction in between the input and the output. And we know that the OSR instruction is used to generate single pulse only. See, here I am releasing the push button and pressing it. Again, it will generate the pulse on the output side. So here, you just observe the output coil. It will generate it will send the pulse, and it will energize the output for a second and turn off immediately. Okay, means in order to execute, in order to perform and implement the discussed condition, the condition number 1 and condition number 2, we need to design logic for the same. So go offline now. So in the previous session, we have already discussed about the logic gate. So in this project, we are going to use the concept of logic gate. That is nothing but the XOR gate. So as we know that the expression of the XOR gate, here I am just typing or mentioning the expression of XOR gate for your understanding. Okay. The expression for XOR gate. XOR gate. So that is nothing but A into B bar plus A bar into B equals to Y. Right? Click on. So this is the expression for our XOR gate. Okay. Now, okay. So initially, we need to select the symbol so that the comment will not be go down this rung. Again, edit title and paste description. Okay, now our task is to design the logic for this project. So we have already discussed how to design ladder diagram by using this expression. Now the dot means what? The AND gate is a series operation. A into B bar plus A bar into B equals to Y. So we don't know about the second input. Okay, as we know that the pulse is received by this output coil, so definitely we need to use this output address on input side. Then and then we can able to transfer this DC pulse to our motor. So initially here we need to add the output of motor. So here I am adding the output of motor. Double click and provide the tag and the description as well. So I'm just providing the description shortly. On off operation. Press OK. Now here you can see, as I have mentioned in the project description, we need to use the holding operation. So holding operation means what? We need to connect the output address in parallel with the input address. Okay. We need to connect the output address in parallel with the input address. Okay. But simultaneously we have to design the ladder diagram for XOR gate also. Okay. So if you are connecting the output of this motor in parallel with this receive pulse or with this binary address like this here, simply what we can see, so this is known as holding operation. Okay, means this is the input number 1 and this one is the input number 2, simply input A and input B. Okay, now we can able to design the ladder diagram for this expression. Now this is the input number A, and for the B bar we need to use this input. So B bar means what? We have already discussed. B bar means normally close contact like this, and A bar. So A bar means what? Normally close contact again. So here we have successfully designed the logic by using the XOR gate. Okay, and if you don't know about the XOR gate, so that will be more difficult for you for designing such a logic. So right now we have designed this logic very easily. So this is possible only by using the logic gate. Okay. So always remember, so as and when you are thinking about the remote control operation, you can directly use the logic of XOR so that you can able to complete the program easily for the remote control applications without any hesitations and taking too much time. Now verify the program and let us run the project. See, so as per the condition number 1, when we press the button, see, when we press the button, you can observe the motor will start, and even if when we release the button, the motor will continue to run. So let us see what will happen. Here I am releasing the push button. Yes, you can see the motor is continue to run. Okay, the motor is still running. Now let us assume that we have completed the work which is assigned and which is based on the motor operation. Now it's time to turn off the motor. So how to turn it off? So again we need to use the same button to turn off the motor. So what is the condition number 2? The condition number 2 is that when we press the start push button again, the same start push button again, the motor will stop. Let us see. Yes, motor is stopped now. And even if you release the push button, the same push button again, the motor will remain off. Yes, definitely we have successfully applied both the condition in the project number 1. So this is how you have to design the program and run the program in your system. Now this is all about the project number 1, and in the next session we are going to discuss about the project number 2. Thank you.